The first kind of series we'd like you to be very familiar with is a geometric series. And a geometric series is a series that is generated by taking the first term and multiplying it by a common ratio, or multiplying it by the same number every time to generate the rest of the terms in the series. So one we've already looked at would be the series that looks as 1 plus 1/2 plus 1/4 plus so on and so forth. Notice that our first term, we'll call A, and I think your textbook uses that, is 1. It's our first term, and the common ratio R equals 1/2, because if you take any term in the series, we'll take the third term, 1/4, and divide it by the term before it, in this case 1/2, you get the common ratio. It's a ratio between the, say, n plus 1 term to the nth term, or the ratio of the term over the one that came before it. Now, we can find this a few different ways, and these problems have always amazed me, but I'm going to show you a different way to approach it. And the first would be that we know that if this thing has a sum, we can call it S. And by the multiplication property of equality, I can multiply both sides of this equation by 1/2. And if I were to multiply the right hand side of the equation by 1/2, 1 times 1/2 is 1/2, and 1/2 times 1/2 is 1/4, and I'm just going to keep generating every single term in the series, even though it's infinitely long, with the exception of the first one. Now what's nice about this is when I subtract these two equations, 1s minus 1/2s is half s, or half the sum, and the right hand side, every term cancels out with the exception of the first term. If half the sum is 1, then the entire sum must be 2. And I love this approach, this intuitive approach to finding these types of sums. And we can generalize it a little bit and use that same approach to talk about the sum of any series, geometric series. So we could have the sum would be equal to the first term, and the second term is always the first term times the common ratio, and the third term is always the second term times the common ratio again. So we've got something like this. Now if we were to multiply both sides by R, we would end up with, again, every single term in the series, with the exception of the very first term. A little subtraction, we have S minus RS is equal to the first term, and if we factor an S out, and divide by 1 minus R, we have this. And this is the formula to find the sum of any infinite geometric series. Now there are a couple things, stipulations about this. And the first is that the common ratio must be less than 1. As far as greater than 1, and that just means the numbers are getting bigger and bigger and bigger, and the sum is just growing all the time, right? There's no limit to the partial sums. And if R is 1, the sum is still growing. by the same value every time, but it's still growing. If the sum is less than 1, that means that the terms in the sequence are getting smaller, and so the limit of the nth term, the last term, is heading towards 0. So this is the stipulation. You ought to have this formula memorized, and if you can recognize a geometric series, which is always generated by a first term times some common ratio, then that's going to be the rule. Typically it starts with 0. Then you can know quickly whether or not you have a sum, whether this converges or diverges, right? If r is less than 1, this thing will converge. If r is greater than or equal to 1, then the geometric series will diverge.